Okay, good evening once again. Now let's start from where we stopped in our last class. Our last class, we looked at the concept of Black-Scholes option pricing theory, and we solved a question on that topic. So we proceed today by looking at other questions in option pricing. Now, I've sent the solution to this question to you. Have you seen it? Ms. Angela?
No, I've not seen.
The solution you requested, I've sent it to you.
Which one?
What you requested, and the question we did not solve.
Yeah, I'll check it now.
That question we did not solve.
Okay.
Major and Avion that we did not solve. That I said I will send. I've sent it.
Okay, check it.
Okay. So this is where we are. We have solved this question. Okay. Though we are left with requirement B. We are left with requirement B. And what does requirement B ask us to do? Requirement B requires that we explain briefly, without any calculations. Explain briefly, without any calculation, how a decrease in the value of each of the following variables is likely to change the value of a call option. One is volatility. 2, risk-free rate of return. Now, what does volatility measure? That's the first thing you need to know. When we say volatility, what does it measure? Volatility measures the degree of deviation, okay, of the value of a particular variable. The degree of deviation of the value of a particular variable. Now, volatility can also be called what? Standard deviation. Okay, so when we say volatility, how volatile this thing is, it means how unpredictable it can increase, it can reduce. So volatility means standard deviation. And that means the amount by which the price of the underlying asset currently is likely to differ from the price of the underlying asset on the date the option will be exercised. Let me make it clear. Number one, I said volatility measures what? Volatility measures the degree of deviation. When we say deviation, deviation is the value you expect, okay? The difference between the value you expect and what? And the actual value that occur. That is deviation. I'm expecting 10 naira, but I got 8 naira. So what is my deviation? My deviation is 2 naira. Do you understand? So let us say that currently, today is November 4. Value of my underlying asset on November 4 is 45 naira. Now, on December 4, the value has gone to, okay. The value has now gone to, let me say, 50 naira. So, what measures the degree of the difference? What measures the degree of the difference of these two values is what we call standard deviation. That is what we call standard deviation. So standard deviation measures the degree of the difference between the actual value you expect, or let me say the expected value you expect, and the actual value that occurs. That is what standard deviation measures. Now, let us go and relate this to value of an option. The question says, explain briefly how a decrease in the value of each of the following variables is likely to change the value of a call option. Now, let me tell you, if my standard deviation is 10, for instance, my standard deviation is 10, and the option price, and the value of the underlying asset as at that time is 50. And now my standard deviation drops to, it decreases to 8. What do you think will happen to my value of my underlying asset? A decrease in standard deviation will increase the value of the underlying asset. So when the likelihood of this value change decreases, the price of the underlying asset is expected to go up. So a decrease in volatility, we make the value of the underlying asset to increase. Are we together?
So you said decrease in volatility will make the value of the
underlying asset, yes. It will increase it.
To increase.
Yeah.
Okay.
Yeah. While a decrease in risk-free rate will have the same effect, because if your risk-free rate decreases, it means the present value of the exercise price reward will increase, isn't it? The higher the discount rate, the lower the present value. The lower the discount rate, the higher the present value. Are we there? So let me go and show you here. I'll go back to that call formula. This one here. Look at it. If this RA, that's the risk-free rate, that RA is the risk-free rate. The higher the risk-free rate, the lower the exercise price. And if the exercise price is low, it means what you are going to subtract from here will also what? Will also be small. That's the way to interpret this. I already told you that this thing here represent present value of the exercise price. So if the discount rate reduces, did they say reduces or increases? Let me check. So that I won't be giving you wrong information. Okay, it's decreased. Now, if the discount rate decreases, then the exercise price will be what? The present value will be what? Will be higher, Abby? And if the present value is higher, it means the whole value here will be higher, isn't it? So it means we'll be deducting a higher value from here. So what will happen to the price of the asset? So is expected to decrease. You consider just 2 marks, just a brief explanation is what you need there. It's not what you should go and write dictionary on. So, without wasting time, let's go to question number 2. Assuming that your company has invested, look at it all. Assume that your company has invested in 100,000 shares of Major PLC, a manufacturer of light bulbs. You are concerned about the recent volatility in Major's share price due to the unpredictable weather in its home country. You plan to protect your company's investment from a possible fall in Major share price until in 3 months' time, but do not wish to sell the shares at present. No dividend are due to be paid by Major during the next 3 months. Market data. Major's current share price, 200 kobo per share. Call option exercise price, 220 kobo. Time to expiry, 3 months. Interest rate, 6 months. Volatility of Major's share, 50% standard deviation per year. Assume that option contracts are for purchase or sale of unit of 1,000 shares. Devise a delta hedge. Devise a delta hedge that is expected to protect the investment against changes in the share price until winter. Delta may be estimated using ND1. What I will ask you here is that what is happening to these people now? What happened? What is their situation? Their situation is that this company currently has 100,000 shares. He has it. Look at it. The company has it. You understand? The company has it. So, if you have it, something you have, will you buy it again? No. You understand? Something you have, will you buy it again? The answer is no. So it means that this company will be selling the shares in 3 months' time. They plan to sell it in 3 months' time. That's what it means, because they already have the shares. Now, the problem is that the fear is the share price will reduce in what? In what do you call it? In that 3 months' time. Okay? So they want to protect using delta neutral hedge. They want to protect using delta neutral hedge. if you want to use delta neutral hedge, if you look at the requirement says devise a delta hedge that is expected to protect the investment against changes in the share price until winter. If you want to devise delta neutral hedge, you have to calculate number of options required. You calculate number of options required. This is slightly different from what we did in one. In one, we only asked to calculate the price of what? Of the option. And there we assume that one option will hedge one share. But here is delta neutral hedge. Here is delta neutral hedge. This is what we are going to do. The first thing you will do is, you can say, devise a delta hedge. I mean, delta may be estimated as what? ND1. Delta may be estimated as ND1. So the first thing you need to do is to go and compute this ND1. You don't even need the examiner to tell you that data may be estimated by using ND1. Data of call, like I told you in our last class, data of call is ND1. Data of put is ND1 minus 1. So this is what I'm going to do. Example 2. Example 2. Delta neutral hedge. I told you the importance of data in our last class, that we use data to hedge, and we use the formula that what I said your the relationship between your stock market price and what, and the option of price. That's what data measures. So we see the formula in our last class. Now, my data neutral hedge, we first look at what type of option are you dealing with. This company want to sell these shares. Look at it. We want to sell these shares, isn't it? We want to sell these shares because we currently have it. We want to sell it in 3 months' time. So we need what? We need a put option. We need a put option. So I've told you that whether put option, always calculate or always use what? Start with call option. However, I don't need this one here. I don't need all this one. SOND1, no. Why? Because I am not calculating the price of a call option. It is this one here. This one you have here is only used to calculate price. Am I calculating price here? No. The question did not ask me to calculate price of the option. What the question want to see is how many options do I need to buy or sell in order to delta hedge. So what you need to compute is D1 first. When you compute D1, you now go and compute your ND1. So D1 is equal to, we know the formula already. Let me just copy the formula down. Sorry. This is the formula. So I write out my variables. What is my SO? SO is 200. Where's my E? E is 220. What's my standard deviation? SD. Standard deviation is given as 50%. Risk-free rate, R. R is 6%. Am I correct? Let me check. Yes. Yes, correct. Time to expiry, T, is 3 months. 3 months is, don't forget, always express it in number of years. So it's 0.25. Don't forget to convert your period to year. If it is 1 year, use 1. If it is 3 months, take the proportion, please. So I will go and put this in the formula. I will insert this in the formula. SO is 200. Exercise price is 220. Risk-free rate is 0.06. Standard deviation, that is going to be 0.5 square because we are given standard deviation. So this is 0.06. Don't forget that this 0.5 is part of the formula before. So what I'm going to remove is the standard deviation. You now put 0.5 square because you need variance there. So times what? Time to expiry is 0.25. Everything over 0.5. 0.25. So D1 will be equal to, well, let's get our calculator. Let's get our calculator. So I press in open brackets 200 divided by 220, close bracket. I have minus 0.0953. Is that correct? Did you get the same thing?
Correct, sir.
953, okay, plus open bracket 0.06 plus, I will now say 0.5 square times 0.5. That will give me 0.125.
185.
Eh?
0.185.
125.
And what?
It's 125.
It's 0.125. So 0.125 times 0.25. 0.25. So over this. So you press square root of 0.5 Sorry.
So I'm not getting
0.125.
0.125. Oh.
What do you say?
I got 0.185.
1.
Oh, okay. Don't never mind. Me, I need my own together. Don't worry. Me,
Square
I'll
root of
put
0
everything together.
times 0.5. That one will give me 0.25. This one here will still give me 0.25 after the multiplication everything. So my D1 is equal to 0.06 plus 0.125 equal to everything times 0.25, then plus, so it's going to be minus, have you? Minus 0.0953. What do we have? Minus 0.0491. You have the same thing? You have the same thing? Or you are not doing it?
Check.
Minus 0.
So here I have 0.196, approximately 0.20. Yeah, 0.20. That is my D1. That is my D1. I don't need D2. You work with what you want to calculate. I am not calculating price of option here. I want to calculate the number of option. If I want to calculate number of option, I don't need ND2. It is only ND1 that I need. So from here, I'm going to calculate my ND1. Well, 0.5. Go and check 0.2 under 0.00. What will it give you? Okay, sorry, my network went off. So, what do we have? Are you there? What do we have?
So you
Check
said
your normal. Check your
Zero-
normal decimal table. 0.2, that's 0.00.
This D1, excuse me, sir.
Yeah.
This D1 supposed to be a minus 0.20.
Supposed to be
Not
what?
positive.
Oh, sorry, minus. Yeah.
yeah.
Thank you. So,
0.079.
so that's going to be minus.
Minus
0. What?
793.
793. Okay. So remove it from 0.5. What do we have?
Minus 0.293.
Minus 0.293. 293.
Yeah.
Is it not 0.079? Is that zero not important?
Is it not what?
I say what I'm seeing on my
Yeah, 0.0.
Divide this one by this one.
Okay,
This
what
by
you
this is
saying
what?
is it should be 0.07930.
This one?
Yes.
Okay, not 0.7, Abby.
Yes.
It's
Yeah.
0.0793.
Yes. Because on the sheet is 0.0793.
Okay.
Yeah.
Oh yeah. Give me the figure there.
Minus 0.
0.4207.
0.4207.
0.4207.
4207. That is ND1. And this is what we call data of what? This is data of core. This is what we call data of what? Data of core. If you want to data edge, you must know data. If you need something from data, you want to take something from data state, you have to get to data state first now. So if you want to data edge, you must know data. So this is data of core. Why I see data of core? Because it was computed using ND1. Now, but what option am I using? Put option, Abby. So I need data of put. Don't forget, we want to sell the shares. We want to buy option to sell. And option to sell is what? Option to sell is a put option. Do you understand? Option to sell is a put option. So if you are dealing with put option, obviously, you cannot use data of what? You cannot use data of core. You need to get data of put. And how do I get data of put? Data of put will be
So is
equal
that
to
data of call or call of call?
data of call. Data of call. So data of put will now be data of call, which is what? ND, don't forget. Anywhere you see ND1, that is data of call. So data of put will now be ND1 minus 1. So that will be equal to what's my ND1? My ND1 is minus 0.4207 minus what? Minus 1. Yeah, what would that give me? Delta of put is equal to, what would that give me? What would that give me? Oh, yeah, press your calculator.
0.5.
But that ending one is not minus 0.4. It's just 0.4. 0.4207. Could you minus?
Okay, there's no minus there.
Yes.
0.4207. Okay. So this one should not be what? No, there's no minus. If this one is what? 0.5 minus this. Mrs. Angela?
Yes, sir.
There's no minus
Are
there.
we subtracting 0.07 from the 0.500?
Yes, now. It is 0.5 minus this.
Okay.
It's not that way around now. 0.5 minus 0.0793. That's what we are doing.
Delta of put minus 0.5793.
Okay, it will not be minus, Abby.
Yes.
Minus 0. What?
5793.
5793. Please, you people should confirm it too. It's better the way we are doing it together so that everybody is following and then we are able to get any mistake. So don't say because someone has gotten the answer, I will not do it. Do it so that if there is mistake, we quickly identify it. Did you get the same thing?
Yes, sir.
Did you get the same thing?
Yes, sir.
Yeah.
Oh,
Okay. So I've gotten my data of put. And put it there. This is data of put. After getting my data of put, now I now have to go and data neutral edge. How will I data neutral edge? This is what I'm going to do. You have to data neutral edge means I want to calculate number of put option required. You understand? I want to calculate number of put option required. Now, what will I do? I will put security. This is the template. Security, quantity, just like QTY, delta, then total. Now, we are dealing with two things here, shares and option. Abi, share and option. And what type of option? Put. So I will start with share. Write shares here. Write shares here. Now, how many units of the shares do we have? 100,000, right? We have 400,000. Go and put the 100,000 there. 100,000 shares is what I have. What's the data of shares? Now, take this, jot it down now if you have not. Data of underlying asset is always 1. You don't have to calculate that. Data of, what's our underlying asset? Our underlying asset here is shares. Data of underlying asset is always 1. Take note. Data of underlying asset is always 1. You understand? Hello?
Yes, sir.
Okay. So when we are done with this, we now say total. Total is that quantity here multiplied by the data. So 100,000 times 1 is still 100,000, right? Put 100,000 there. The next one we want to put there is what? We want to use put option. So put option there. That is the second thing. Do we know the quantity of the put? No, put X. You can use any letter anyway, but I prefer using X. You can use any letter of your choice. Okay. So what is the data of the core? The one you calculated. What do you have there as the data? Eh?
Data of core.
Yeah, sorry, put.
Okay.
Data of put. Not core, we are using put.
0.93.
0 point.
Minus 0.5793.
Minus 0.79.
5793.
Okay. 5793. Like this, Abby?
Yes.
Okay. So what is the total? Total is this times X. And we have minus 0.5793 X. You now add this together. You add it together. Now say total. Total here will simply be 100,000 minus 0.5793. This is going to be our total, Abby. That's our total. If you add the two together, that's what I'm going to do. Now, in order, don't forget, I said data edge means that you want to take a position such that whatever happens in the market, your share price remains, yes, your share price remains unchanged. That is the data there. So if that is the case, it means whatever I have here, I will have to equate it to what? To 0. I've not put X here. Whatever I have as my total here, when I'm data neutral edging, I will equate everything to 0. I will equate it to 0. Therefore, I will have 100,000. Sorry. I will have 100,000 minus 0.5793 X to be equal to 0. So equate it to 0. So when you equate it to 0, you collect your like terms. I will have minus 0.5793 X to be equal to minus 100,000. So I will divide both sides by what? I will divide both sides by 0.57. So I have X equal to, don't forget both of them, both sides as negative. So I can ignore the negative. I just put 100,000 divided by 0.5793. We are divided. What do we have? What do we have? What do we have?
172.622. Oh no, sorry, 1,072,622.
I don't understand it.
172,622.
One what?
172,622. So confirm. 172,622.
172,622. Abby?
Yes, sir.
Yes.
Now look at it. Let's go back to the comment. The comment says, assume that option contracts are for purchase or sale of unit of 1,000 shares. What does that mean? It means that one option, one put option will be used to hedge what? will be used to hedge 1,000 shares. So number of options is going to be divided by whatever you have there, you're going to divide it by 1,000. That's what it means. Because it is one option that will hedge 1,000 shares. So you now come and I say number of put option is equal to 172,622 divided by 1,000. That will give us what? That will give us what? That will give us 172.6 habit, approximately 173.
Yes.
173 put option. You cannot buy half option, so how do I know whether I'm to buy or to sell? If your figure here is negative, it means you have to sell. If it is positive, you have to buy. Positive means buy, negative means what? Sell. So if after your computation, you're having a positive figure, then it means you are buying. But if you're having a negative figure, you are selling. So according to my computation here, I will conclude that for this company to delta neutral hedge, the company will have to buy 173 put option. That's that about requirement A. Now, we have to comment upon. Hello, do you understand that? Or is there any question? Look at it too. Let me know. Shall we continue?
So can you say the
Yes.
conclusion again? You said for the company to delta neutral edge, the company will have to buy the put
The
option.
question or
The conclusion.
I said the question or the solution.
The conclusion of
I
what?
said the company will have to buy 173 units of put option
Okay.
to delta neutral hedge. Did you get it?
Yes, sir.
Shall we continue now?
Yes, sir.
Now, we have to comment upon whether the option is going to be totally successful. Whether it's going to be totally successful. Now, how will I know whether it's going to be totally successful? We have 100,000 shares. Abi? And we are using 173 what do you call it? Unit of put option to hedge it. So the success of this is that if you look at A now, from A, we're supposed to have like 172.6, Abby. Now, what I'm going to look at for you to conclude whether it's going to be successful or not is that what you have computed here, is it enough to cover all your shares? Okay, I have 100,000 shares, and one option will cover what? 100,000. So what you have computed here, is it enough to cover that 100,000 shares? If yes, then you say the option is likely to be what? Successful. If not, it might not be successful. So that will have no calculation at all. You don't have to calculate anything, it's just explanatory this thing. Okay.
Can you help us explain by way of notes so that we can put it down to if you want to recall?
Okay. The option is likely to be successful, we're right. The option is likely to be successful because the number of put options can successfully hedge the 100,000 unit of shares. The 100,000 unit of shares. Okay. Are we done?
Yes, sir.
Yes.
Let's look at the next one. Given investor can diversify away all risk by including the shares of the company in a portfolio, explain why company will choose to hedge against risk. Given the investor can diversify away all risk by including the shares of the company in a portfolio, explain why company will choose to hedge against risk. Do you understand that question? You know, when you are buying or when you are investing, it is expected that you don't put all your money in a single investment, right? You don't put all your money in a single investment. You are expected to put your money in various investments so that when one is performing, when one is not performing, the other will be performing. Therefore, if you put your money in just one, that is what I'm going to discuss in portfolio theory. Now, if you put your money in one single investment, whatever happened to that investment will affect all your money. So for that reason, it is good for a company to what? To hedge. Okay? This question is now saying that given that investor can diversify away all risk by including the shares of the company in a portfolio, explain why company will choose to hedge against risk. Company will choose to hedge against risk because portfolio theory and capital asset pricing model. You see, you know what?
Please, you're writing, Nadia.
Don't write. You won't stop. Please, suspend this. There's no way I can explain this to you now that it will be clear to you, except we take portfolio theory. Otherwise, we just write it down without knowing what I'm talking about.
Just say it, we'll understand. When time comes, we'll understand better.
Okay. So investors will need to hedge against risk. Investors will need to hedge against risk because portfolio theory and CAPM, which is capital asset pricing model, assume that investors, are you there?
Yes, sir.
Should concern themselves. Investors should concern themselves about systematic risk alone. However, investors' risk exposure, investors' risk exposure investors' risk exposure is the total risk of their investment. Is the total risk of their investment. Therefore, investors need to be concerned with total risk. And this is achieved, and this is achieved, and this is achieved by hedging against risk. So that's that about that. Briefly discuss the meaning and impacts of the following text: delta, theta. So I've explained those ones earlier. So you just go and look at them. Let's go to question 3. Are we there?
Yes, sir.
An investor holds 500,000 shares of Benko PSC and is considering buying some put option to hedge our investments. An investor holds 500,000 shares of Benko PSC Okay, sorry. Let's continue. Benko's current share price is 16 naira. The risk-free rate is currently 12%, and recent volatilities, which is standard deviation of the shares, has been 30% per annum. She requires a European put option with an exercise price of 50 naira and expiry of 2 years. Required. Calculate the value that a bank is likely to charge for 500,000 put option of the investor's required specification. We don't want to do this. I'll be guiding you. I won't do it. Yeah. Who can tell me what you are supposed? How do you start this question first? Look at it. How do you start? So this is very simple. It's very, very simple. Hello, are you there? Let's attend. Let's talk. Let's talk. That's how you can evaluate yourself. Let's talk. Hello?
Yes, sir. We'll
Can you hear
calculate
me at
the
all?
one first.
Eh?
Calculate our
You do
D1.
what?
We can put D1 first.
Now, the first thing is, what do you want to, what option are you dealing with?
Call option.
Like now, the question has told you, point blankly, look at it.
Considering buying
Buying.
some put
Yes,
option.
now, are you buying?
Buying is
Buying is what?
Buying is call option.
Buy what? Buying collision. What are you buying? Why? What will determine whether you are using call option or put option is what? Is it not the underlying asset? If the underlying asset is what you are doing to the underlying asset that will determine your option you are buying now. The underlying, you already have these shares, you want to sell it. And the question has already told you that you are buying put option. You want to sell these shares. This is the underlying asset. That's what you want to sell. You already have it. You already have these shares. You want to sell. Hello?
Yes, sir.
So you already have this. You want to sell.
So buying some put option.
Yeah, considering buy. If you are buying put option, doesn't mean that you are using call. You use call to buy option. It means you are using option to buy option. No, now. You have these shares presently. You have these shares presently. And that is what you want to sell in the future. For you to sell in the future, you need a put option. The question has told you there that the investor want to buy a put option, is considering buying a put option. Is that put option that will give you option to sell in the future? That is in 2 years' time. So what I expected you to say is that we calculate price of call option first, then using put call parity to calculate the price of a put option. Whatever you have there, multiply by 500,000. This is exactly the same question we're solving in exactly the same thing what we solve in example 1. Exactly the same thing. Oh yeah, attempt this. Attempt this. Let's go there. You'll be telling me what to do. I won't do it. You'll be telling me what to do. It's not that I will solve 4 questions. When I go to the exam, you'll be seeing 6 questions. You'll be able to attempt it. Example 3. Well, what do I do? What do I do? I'm waiting for you people.
D1.
The question.
Can put D1 I'll put ND1. ND6.
Okay. You bring your formula down first. You want to compute. Does it have requirement B or just A? Yeah, A. Computation, this is how we start it. Computation of the price of 500,000 put option. Price of 500,000 put option. That's what we want to calculate. The price of 500,000 put option. So bring down your formula. I bring down this formula. So what is our SO? Invariably, I'm sorry. You should not be happy when I'm solving all question for you, honestly. At all. You should not. If I'm solving the all question for you, it means there is a big problem. You can never get option pricing theory question that will be simpler than this. To be frank with you, you can never. That will be simpler than this. It's not possible. So please, what is the price of the dollar asset, which is 60? That is the price of the presently. What is the exercise price? Need to reduce. Sorry, I think this thing was wrong with it. Okay, so what is the exercise price of the share? Exercise price is 50, volatility 30, 2 years maturity. What's the risk-free rate? 12%. So 50, volatility, that's standard deviation, 30%. Hope is standard deviation of variance. Standard deviation. Okay. Standard deviation. Risk-free rate is 12%. Risk-free rate 12%. Time to expiry is 2 years. Time to expiry is 2 years. So put all this in the formula. I will have 60 over 50, 0.12, 0.3 square times 2, 0.3 times square root of 2. Are we following? So I pick my calculator. E1 is equal to dy is equal to, I press my calculator in let's do it together in 60 over 50 close brackets. That is 0.1823. Did you get the same thing?
Yes, sir.
0.1823. 0.1823. Okay. Plus open brackets. Because I'm taking it slowly so that everybody will understand. That is why I'm taking it slowly here. So I'll now put 0.3 square times 0.5. That's 0.045. 0.045 close bracket times 2, everything divided by square root of 2 times 0.3. That is 0. I'm coming, but I've not made a mistake. Square root of 2 times 0.3. Is 0.4243. You have the same thing?
Yeah.
Okay. 0.4243. So D1 will be equal to 0.1823 plus, I will now say 0.12 plus 0.045 equal to everything times 2. What do I have there?
1.35.
0.045. 0.33. Do you have the same thing?
Yeah.
Okay. Make sure you understand option. Option is one of the areas where you can get a very cheap mark, very cheap, honestly. 4243. So D1 will be equal to, add together 0.1823 plus 0.33, everything over 0.4243. 1.2074.
Yes.
Yes,
How
sir.
about 2074? Or I will call it what? Decimal place.
1.21.
1.2.
Yes.
1.21. 1.21. That is my data of core. That's D1.
Oh.
So,
Sir,
yeah.
I did not get the same answer with that 0.2 times square root of 2.
0.2
times square root of.
What did you get? What did you get? No, not 0.2, now 0.3 now. So now that's a mistake now.
Okay. Okay.
So we're not going to compute what?
ND1.
That ND2. We're going to compute our ND2. Before, sorry, D2. D2 will be equal to D2 will be equal to D1 minus this formula here. So D2 will be equal to, what's our D1? 1.2074 minus, what our this was 0.4243. 0.4243. So what would that give me? What would that give me?
0.78.
0. What?
783.
0.783. So I can say 0.78 to 2 decimal places. I've gotten my D1 and D2. So what about ND1 and what? ND2. ND2. ND1 I have 0.5. Is my D1 positive? Yes, put plus. So go and check 1.2 under 0.01. 1.2 under 0.01. What do we have?
Sir?
Oh yeah.
Uh,
1.2 under 0.01.
Why
One-
under 0.01?
Okay, 1.2. 1.2 under, is it 0.01?
So why is it under 0.01?
It is
When-
under 0.01.
When our T1 is 1.21 or 1.2.
So what will it be? The one you did before, how did you get it? What did you do here? This one you did, how did you get, where is it? Where do you do that? How did you get this one?
Zero 0.2 under 0.00.
So
Okay, this one
if I now
under
put one here and I put one here, it should not be what?
0.01.
Yes, now. 1.2 under 0.01. The same procedure. There's no any difference. Don't go and confuse yourself.
0.3869.
0.3869.
Yes.
Okay. So when we add the two together, it should be 0.8869. I'm correct. Is that correct?
Yes.
So the second one here, is it positive or negative? Also positive, Abby? So 0.5 plus, oh yeah, 0.7, that's 0.08.
0.2823.
0.2823.
23.
Oh, okay. I got your confusion. Let me go back to that place. Let me use example here. I think I was just thinking about why you were confused and saying why is it 0.2, but I now understood what you thought of. So because I said 0.2, Abby, and I also say 0.02 again, right?
Yes.
And that's what is confusing you. Now look at it. Why this one is so easy is if I have 0.20 and I said always pick the first what? The
Yes.
first 2 digits, Abby. What is the first 2 digits? 0. What? 0.2. So if you remove 0.2 from 0.02, sorry, if you remove 0.2 from 0.20, what will you have? What will you have? Toku. You have to think about that.
0 now.
Eh?
0.
So that's why this one is 0.2. The balance is what? Is 0.00. But for this one now, this one is what? Sorry. This one is 1.21. If you remove the first 2 digits, that should be 1.2, Abby.
Yes.
So 1.2 minus.
Okay, 0.01. Okay.
1.21 minus 1.2 is what?
0.01.
So did you get it now?
Okay, yes, sir.
So the first 2 digits you pick first. We have to subtract it. The balance is under where we are going to check that figure.
Check that figure. Okay.
So we have gotten our ND1. We have gotten our ND2. ND2 is 0.7823. 823. Now, I can now go and calculate my call option. My call option price will be SO. Where's our SO? Our SO is 60 times ND1, 0. Are you there?
Yes.
0.8869. Close the bracket minus. What's our exercise price? 50 E raised to power, open bracket, minus R. Where's our R? 0.12 times 2, which is T. Which is T. Everything here times ND2. ND2 is 0.7823. 0.7823. That's our ND2. So call option price is equal to, what I multiply? 60 times 0.886. That's 53.214. 53.214 minus. Oh yeah, I believe you still remember how to calculate our exponential 50 second function in, okay? Are you there?
Yeah.
Okay. So in exponential put your distance is minus. Don't forget your bracket too. Open bracket minus 0.12 times 2. Close the bracket. Press equal to for that one first. I have 39.33. 39.33 times 0.7823.
Help me, I'm not getting it. I'm getting error.
You didn't put it well. You put it well. Very well.
How do I put this?
Eh?
Second function, lean. Shift, lean, sorry. The rest of power, open bracket.
50, press that 50 first.
Oh, okay.
50, second function.
Lean.
Now press the lean there.
Okay.
Now press open bracket minus 0.12 times 2, close the bracket, equal to.
Okay. 39.33.
What do you have?
39.33.
So, and I say my call option price. And you what?
Something in the last class that this exponent, this E raised by is the same as the present value of that exercise price.
Yes.
Can we just do present value? I did present value, but I got 39.85, not 39.
39 point what?
85.
I told you it will not give you exactly the same thing, but approximately.
Yes.
You not get exactly the same thing. They are approximately the same thing. You understand? Eh?
Yes, sir.
Okay. So we have 39.33 times 0.7823. 30.76. 30.76.
77.
77, have you? Okay, 77, yeah. 30.77. So call option price is equal to, yeah, remove that, 53.214 minus 30.77. Mrs. Shiva, are you?
22.44.
Mrs.
Yes,
Shiva,
sir. Yes, sir. I'm here.
okay. Okay. Are you getting it?
Yes, sir.
Mrs. Angela, are you getting it?
Yes, I finished calculating.
Okay, thank you. Now, we have gotten our call option price, but you know the option we are using is put, Abby. So I will now say using put call parity, PCP, put call parity, compute the equivalent price of a put option. Compute the equivalent price of a put option. So what is my put call parity? C plus E. Let me go and copy it there. Plus this C plus this is equal to P plus S. That's my put call parity formula. So I have gotten my call option price, which is 22.44. I'll now say plus present value of exercise price is 39.33 which is equal to put option price plus price of the underlying asset 60. So add these two together, 22.44 plus 39.33. I have 61.77 equals P plus 60. When I make P the subject, I have my P to be equal to 61.77 minus what? Minus 60. So P will be equal to 1 point what? Abby? That's my put option price. That's my put option price. And what does the question say? Calculate the value that a bank is likely to charge for 500,000 put option. So how much will bank charge for this option? The 1.77 times 500,000. So total price of 500,000 put option will be equal to 500,000 times 1.77. 1.77 times 500,000. So the bank is going to charge 885,000. As simple as that. Is there anything difficult here? Yes or no? Is there anything difficult?
Most important thing is
What is it?
the question. The main thing is for one to understand the question.
Did you understand this? Did you understand? Okay, let's go to B. Let's go to B. The question says that is the investor's position, which is what the clearly here from A, you see that The investor is using 500 put option to hedge how many shares? 500,000 shares. Abi, look at the number of shares. This is the number of shares, and it's using 500,000 shares put. The question is now asking you, is the investor's position properly hedged? Okay. Is that position properly hedged? If yes, explain why. And if no, advise on the number of put needed for proper hedging. Now, before you can know whether this is properly hedged, you have to go and compute how many put option will I need for me to hedge 500,000 shares. That is delta neutral hedging. The one we did in question 2. Is this we are going to do. We have to calculate the number of put needed. So if you compute it and it's 500, that's okay. The investor position is properly hedged. But if it is bigger than 500,000, then you conclude that the investor position is not properly hedged. So this is what I'm going to do. B, computation of number of puts option needed. Computation of number of put option needed. Computation of number of put options needed. So, what is our data of core? That's ND1. What's our ND1? Our ND1 is, what do you have? Give me now.
0.8869.
0.8869. Now compute what? Data of put. Data of put will be equal to 0.8869 minus 1. And that will give me what? That's going to be, yeah,
Minus 0.113.
minus
1131.
0.1131, have it? 1131. That's the data of put. So I will now say, the same way we did the other one, I will come and say security, quantity, delta, then total. Security is shares, quantity is 500,000, delta is 1, 500,000. Then I need put option. Put options. I don't know the number, but I know that the data is minus 0.1131. So I will have minus 0.1131x. So add this together. I will have total equal to 500,000 minus 0.1131x. So I will equate this to 0. And say 500,000 minus 0.1131x is equal to 0. So I will have 0.1131x equals 500,000. So divide both sides by what? 0.1131. So I have 500,000 divided by 0.1131. My x will be equal to what? My x will be 500,000 divided by 0.1131. My x should be 4,420,866. 4,420,866. So I can conclude that the investor's position is not properly hedged, or it's not hedged. It's not hedged because the number of put options required is 4,420,866 and not 500,000. So that's how you conclude on that. Now, because this figure is positive now, the investor is going to buy. Is going to buy. If it is negative, you say it will sell. And I've told you, whenever you are buying, you are taking a long position. Whenever you are selling, you are taking a short position. Good. C. Refer to position in A. Calculate the investor's change in wealth if she buys 500 put option to hedge her portfolio, and the share price in 2 years' time is 30 naira per share, 100 naira per share. Now, what does the question want us to do here? You know the current share price is what? Is 16 naira. This is the current share price. That is the current share price. And the exercise price is what? The exercise price is 50. Now, look at it. If in 2 years' time, the share price has fallen to 30 naira, will he exercise his right, or sorry, will she exercise her right or not? Answer that question. Nobody can answer it. Okay. If the share price currently is 16 naira and I have entered to sell at 15 naira and the price dropped to 30 naira, I will exercise my right. If I exercise my right, I will sell 500,000 shares at 15 naira each. But if I had not hedged, look at it. That's what I'm saying. See. Computation of investors' position. Computation of investors' position. Sorry, 1 minute. Mo wò pé ta ló wá rìn ní ilé kápá lóru. Okay. Now, the first one is what? Roman figure 1. If the share price in 2 years, if the price in 2 years is 30 naira. Now, the current share price is 60 naira, and in 2 years' time, the price has fallen, and I have already entered into an agreement to sell at 50 naira. So I will exercise my right. So sales of shares will be 50 times 500,000, because I will exercise my right and sell at that price. So 50 times 500,000. I will collect 25 million. I will collect 25 million from the sales. But don't forget, I will also pay what? I will pay premium. My premium should be removed from my revenue. The premium I'm paying is 1.77. 1.77 of what? 500,000 shares. 500,000 put option rather. That's what you computed as. What do you get there? 885,000. That's paid premium of 885,000. Remove it from there. What is the profit? What is the worth? Not profit. Net receipt. Net receipt will be 24,115,000, right? Am I correct? Yes. So okay. This what it will receive. This is the net it will receive. But before this, if he had sold it immediately, okay, current selling price, if he had sold it immediately, the current selling price, okay, well, let me go take you to this. Just stop there, don't worry. Just stop there. This investor's changing price. Don't go to the other one, that I don't complicate it for you. Number 2, the same thing here, but now, if the share price in 2 years is 100 naira. Of course, if the share price is 100 naira, he will not exercise his right, because if he exercises his right, he will sell at 50 naira. So he will simply go to the market and sell at what? 100 naira. Because we are dealing with put option. He won't exercise his right, because it's better not to exercise the right. If the investor does not exercise her right, she will sell at 100 naira. But if she does exercise her right, she will sell at 50 naira. So it's better she does not exercise her right. So what will be the sales? The sales will now be 100 times this. That will be 15 million. 15 million. So this one still remain this 885 still remain. That's the amount he paid. So I will have 49,115,000. That's what the question wants you to do here. That's requirement 3. So I'm not going to, like I said earlier, I'm not going to binomial option pricing. I'm not going to binomial. All these are the remaining one here. They are binomial option pricing theory. So I won't bother you with binomial. Okay, I won't bother you with binomial option pricing. All these are binomial. Now, the next thing we are going to look at, though not today, I have to go to bed too, so that we can go to work tomorrow. The next we are going to look at in our next class, we are done with optional.
So please, can I see your notes?
We are done with that. This is everything you need to know about offshore. Have you seen my notes? So in our next class, that will be on Sunday. We're going to look at portfolio theory. We're going to look at portfolio theory.
At what time on Sunday?
The same time.
10.
Most likely to be 9.
So let's make it 10.
No problem. Any question before we call it a day? Are we fine? Hello?
Yes.
All right. So let's call it a day at this junction. We meet on Sunday by God's grace. We should be able to finish option portfolio theory on Sunday. Then probably Monday or Tuesday, we'll take a bond.
We have just 1 week to the exam.
Yeah.
I thought we should finish everything on Sunday so that we have time to read.
How do we finish portfolio theory and bond on Sunday? We can't do. So we have to take class on either Tuesday or Monday. We take bond. Please, either Tuesday or Monday. You hear? You still have like all of you. Okay, who is writing to paper? Is there anyone that's writing to paper?
I'm writing to.
Okay, sorry. Don't worry, we round up on either Monday or Tuesday so that we can do the remaining project.
Monday.
Eh?
Let's make it Monday.
No problem. Depend on you. If you say Monday, I'm available. We take it on Monday by God's grace. So Sunday and Monday, right?
Yes, sir.
All right. Thank you.
Thank you, sir.